Hello, this is Ms. DB. In this video we are going to learn about exponential growth. So we're going to graph some exponential functions and they're going to follow their pattern. So on the worksheet we'll see the general form of an exponential function is y equals a times b to the x power. So a is the initial value, your starting value. B is the growth factor. So it's how much it's growing, how fast it's growing. And the exponent is x. So the variable is in the exponent. They'll usually give us a and b, and we'll put the x in the exponent, and then we'll have to answer some questions about it after we graph it. So if we're talking about exponential growth, then that number b will be greater than 1. So here's another, this is kind of the same thing, same setup for the general form of the equation for exponential function, exponential growth. In this one it shows what it would look like if it was decay. Then that b there would be between 0 and 1, like 0.1, 0.8, something like that. But if it's greater than 1, then it shows growth. It won't be equal to 1. It cannot be equal to 1 because if it was, then it would just be a constant function. So here's an example of a graph for growth. It starts out kind of slow and then it rises pretty quickly. Decay over time will decrease and it'll approach. This is y equals 0, but it'll never touch it. So this is decay. So number 1, don't miss question number 1, says what is the general equation for an exponential equation? What do the variables represent? So you can either find that up here, or you can find that at the top a little bit higher. We talk about what a is, what b is, and what the variables represent. And then there's a couple more questions just talking about exponential functions and what those equations look like. Remember that a linear equation would be something like y equals some number times x. So the difference in an exponential growth equation is that we will have the exponent will be the variable. It's actually a times b to the x power, but the same idea where the exponent is a variable, whereas in a linear function you're just multiplying, you're not raising it to a power. Alright, so let's look at how to graph exponential functions. The trickiest part is when we have x as a negative exponent. So we're going to complete a table by finding the value, and then we're going to plot some points and then graph. So for the first couple of values of f of x equals 3 to the x power, we plug in the x values for the exponent. So we'd have 3 to the negative 2 for the first one, and then we simplify this and then write the answer in this one. So remember that from your worksheet on negative exponents that this means 1 over 3 to the second power. So moving it makes it a positive exponent. And then we can do 3 to the second power, that's just 9. So we have 1/9 for our first table value. So when x is equal to negative 2, y is 1/9, which is a small number, but about there. And then when x is equal to negative 1, 3 to the negative 1 is the same as 1 over 3 to the 1, which is the same as 1/3. Still a very small number. For negative 1, it's at 1/3. Now what about to the 0 power? What's 3 to the 0 power? Anything to the 0 power is 1. So when x is 0, we're at 1, which is, you know, this is going up every 2 units. So mine are a little high. And then we let x be 1, and that's just 3. So at x equals 1, we're at 3. And then at x equals 2, 3 squared is 9. And then to the third power, 3 times 3 times 3 is 27. So it starts to rise quite quickly at that point. So when x is 1, y is 3, I've got that one. When x is 2, y is 9. And when x is 3, y is 27, which is, here's 18, so 20, 24, 20, it's like way up here. So to draw this is a little bit tricky, but you're going to try to draw a smooth curve that goes and increases rapidly. Now we could have also graphed this in Desmos, probably a little easier. I'm trying to type x there. f of x equals 3 to the x power. So to get to the exponent, you can use Shift 6, which gives you that little up arrow key, and then type the x. Or you can use the Desmos keyboard down here, and we can use the A to the B button, and that will also let us put an exponent in. And then here's our graph right here. Now I want to see maybe a little bit higher, so if you have to, you can change the scale here. Maybe I want the y value to go up to like 50. And then you just click over here, and now it's changed the y scale. So when you're happy with your graph, you have two ways of sharing that graph if you didn't want to draw it. One way is to get a link. So click on Share Graph. You'll get a link here, copy that, and then you can paste that right onto your worksheet. After you paste it, hit the space bar once and it becomes an active link so that I can click on it. The other way is to take a screenshot of this. So in Windows computers, there's something called Snip and Sketch that you can use to take a screenshot. You're just going to draw a box around it. If you draw what you typed in here, I can make sure that you have the correct setup so that if there's something wrong with your graph, I can see, oh, you forgot to make x an exponent, or you forgot something or other. And then I can copy this, and I can paste it here. You don't have to do both the link and the screenshot. One or the other is fine. Make your graph big enough so that I can easily read it. It doesn't matter if you think it looks too big, that's okay. Big is better than small. Alright, on number 5 and 6 you're going to do the same thing, but it's a little bit different because you have a number multiplied by the b to the x. So don't forget that when you do that, you're going to be multiplying after you raise it to the power. So the order of operations is to multiply after you raise something to the power. So the power part comes first. Please excuse my dear Aunt Sally. So this is the exponent part. Do that before you do the multiplying part. So in number 6, we will be doing 3 to the x, and then whatever we get for an answer, we'll be multiplying by 2 to fill in the blanks. So the first one is 3 to the negative 2, and after we get that answer, we'll multiply it by 2. So 3 to the negative 2 is the same as 1 over 3 squared, which is the same as 1/9, and then we have to multiply that by this 2 that's in front. So what's 2 times 1/9? It's 2/9. So our first value at negative 2 would be 2/9, which is a very tiny number. And then our next value is when we have 3 to the negative 1, and then we have to multiply that by 2. So that's the same as 2 times 1 over 3, so that's the same as 2/3. So that's almost, 2/3 is right about, oh, I forgot that this is only going up to 2, so my points are too high. Let me make them a little bit lower. I can't seem to erase that one. Now I have to erase it all. Okay, there. Okay, I'll make them in red. So at negative 2, I was at 2/9. That's 0.22222. And then at negative 1, I'm at 2/3. And now at 0, it would be 1, because anything to the 0 power is 1, but then I have to multiply that by 2. So I'm actually at 2. So we have our points are at 0.22222, and then at 2/3, and then at 0 it's at 2. And then at 1, we would be at 3 to the 1, which is 3 times 2, so that's 6. So at 1 we're at 6, so here's 1 at up to 6. And then at 2, we would have 3 to the second power, that's 9. 9 times 2 is 18. So at 2, we're all the way up to the top at 18. And then you would connect that with a nice smooth curve. Or you can make it over here. So this would be the same exact problem I had before, except 2 times at the beginning. And you can see how that changes your graph. It goes up, spreads it out just a little bit more. Alright, so now we're going to go down to solving. You have a couple questions to answer there, and now we're going to look at exponential growth or decay problems, word problems. So here's the model we're going to use. It's a little bit different than just exponential functions. The initial amount is the same, but this is, instead of b to the x or b to the whatever, it says 1 plus or minus r to the t power. Now the rate of increase, that's the same as b. We could use b there. But the model says that we are going to have to, for exponential growth, we will be adding 1 to whatever our rate of increase is. So make sure you note that. And they'll usually give it to us as a fraction, like 7%, but 7% is the same as 0.07. So if we had that for our problem, we would write 1 plus 0.07, which is 1.07. That's our thing that is being taken to the x power. So there's an example here, and this one's using a graphing calculator, and there's an example here, and this example is very similar to number 10 on your worksheet, so make sure that you look back, and here's an example of the graph and what the size of the graph should be. And then let's look at number 11. Number 11 says that some real estate agents estimate that the value of a house could increase about 4% each year. How long will it take to be worth at least $130,000? It doesn't say the original value of the house. It seems to be missing from my worksheet, but it's a value of a $100,000 house. Okay, so A is how much we're starting with, which is 100,000. Don't put the commas in when you put this into Desmos. R is 4%. But that's the same as 0.04. So R plus 1 would be 1.04 or 1.04, like that. And then the equation is when you are going to write out the equation. So it's A, 100,000, times, parentheses, 1.04 to the x power. Now we're going to graph this using technology, so I don't want this graph anymore. And when I do this, we won't see anything graph at first because I haven't changed the scale yet. So don't put the comma in for 100,000. It messes up Desmos, it can't read it. And then I'm going to use the parentheses to show that I'm going to multiply that by 1.04 to the x power. So I can get to the x power like this, and then type x. Now this is graphed. I just can't see it yet. I need to change the scale with my graph settings button, and I need this to go higher than 100,000. So let's go to like 150,000. And then just click away and you'll see the graph now. I'm going to zoom out just a little bit so I can see all of my x-axis too. So there's the starting value of the house, and then you can see it'll increase over time at a not a fast rate, but at 0.04%. All right, so we did D, we changed the scale. Now we're going to do graph E. It says, how long will it take for it to be worth 130,000? So I have to graph another line. I could just say, okay, here's 130,000. What is X right here? But it's hard to see them both at the same time, the X-axis and the Y-axis. So my estimate might be like somewhere around 6, right? So let's just graph y equals 130,000, no commas, at the same time, and then I can see exactly when this will happen. This will happen at 6.689 years, but I'm going to round that to 6.7 years later. And now I'm going to get a screenshot of my graph. So I'm going to click on the, I'm going to use this. So I need a new one. And I'm going to take a screenshot that shows what functions I used. Plus, let's get the x-axis in there. And now I've copied it, and now I'm going to, I've copied it, and now I'm going to paste it into the worksheet. And I'm going to make sure it's big enough for the teacher to read. I want to be able to see the functions here. I see the graph, I see where they cross, and then I'm ready to move on to the next problem. Now on 12, 13, 14, up to 16, you only have to pick 2 of these. But you'll do all the same stuff. You'll write the equation, you'll graph it, you'll answer the question. Let's look at number 13. A set of bacteria begins with 20, so A is equal to 20, that's our starting value, and it doubles every 2 hours. Well, doubles every 2 hours means we have to figure out the rate from this one. And then it says how many bacteria will be present 15 hours after the experiment began. So in number 13, I'm changing it to doubles every hour, so it's not too complex. So that means that at time is 0, it would be at 20, and then after 1 hour it would be double, and after 2 hours it would double, and after 3 hours it would be double what it was before, so we keep going at that rate. So the rate is 2. So our formula is, our equation is f of x is equal to a, 20, times 1 plus our rate to the x power. So let's go over here and graph that. Oh, I didn't put in my rate. Actually, the rate would be 1 because it's going to be 100% more each time. So 2 is what you would get if you simplified this. 20 times 2 to the x power. Alright, so we'll graph this and make sure that it matches what we want it to match. F of x is equal to 20 times 2 to the x power. And we can double check that these values would make sense. So at 0 it's at 20, yep. At 1, right about there, we had 40, yep. And at 2, we were at 80. So these values are matching what we had for our table here. And then what else do we have to answer? How many bacteria would be present at 15 hours after the experiment began? So we could look for 15 on here, but this is going to be a really big number. See, 15 is here, and I can't even see that yet. So let's change our scale. We're going to have to go quite a bit higher. Let's go up to 1,000. See if we can see 15 now. So I don't think I can see it yet. Y equals, no, x equals 15 is what I need. I need the time to be 15. So it's going to be so big if it doubles every hour because it's such a fast increasing rate that I still can't even see it. Let's go up to 10,000 and see if we see it. We're trying to find when these two would match. It's a very large number. Here's where they match. So after 15 hours, it's going to be way up here somewhere. 15, look at that. It's at like 650,000, somewhere in there. 655,360. So when you're increasing, if they are going to double every hour, that is some really fast growing bacteria. But that's how you would answer it from this problem. And then the graph of this is going to be a little bit tricky because you can't see everything at one time unless you really zoom out. So where were we at? Somewhere around here. Too high. There it is right there. If you click on this, it'll actually, if you find the actual intersection, it'll stay dark like that while we take our screenshot. Now let's say for this one I'm just going to get a link to the graph. There it is. And then you can put this in for the graph. Put a space bar. And then to answer the question, we had our answer was 650 some. There it is. 655,360. 655,360. Big one. So the other ones, I think this one, your rate is 1.2%. So when you add 1 plus 1.2, you will get 2 point, oh wait, that's 1.2%. So as a decimal, that's 0.012. So when you add 1 to that, you'll get 1.012. You'll use inside the parentheses. Let's look at number 14. 2.3 is the same as 0.023. So that's your R, and when you add 1 to it, you get 1.023. So these ones won't add up as quickly as that last one we did. And then number 15 is a little bit challenging, so if you try that one, good for you. And remember, you only have to pick 2 of these to do. All right, thanks very much and have a great day.